Second, ask your friends to join. Okay, I'll continue. In designing of shafts, in designing of shaft, the shaft what we are designing is based on two criteria, either strength criteria, which is based upon torsional strength, that is tau, shear strength tau, torsional shear strength tau, or rigidity criteria, stiffness criteria based on angle of twist. Okay, this problem is about that. A solid shaft is subjected to a maximum torque. It is nothing but you can write T max if you want, or you can leave it. T max, which is equal to 25,000 kilonewton meter. 25,000 kilonewton meter. I always express my torque in Newton mm. 25 into 10 power 6 Newton mm. Okay. Find a suitable diameter. It's a solid shaft. Find a suitable diameter of a solid shaft if the allowable shear stress and angle of twist is limited to 80 Newton. Allowable twist is 80 Newton per mm square and angle of twist is theta, which is equal to 1 degree. Convert it into radians, 1 by pi by 180. Tell me, for a length 20 times the diameter of the shaft L, which is equal to 20 times the diameter of shaft. First, tell me theta in terms of radians. Theta in terms of radians, pi by 180. How much? How much? Pi by 180.
0.0174.
Others, why you are not speaking?
0.01744.
Yes, 0.0174. Okay. Based on strength criteria, there are two criteria as I have told you. Based on strength criteria, we know that first you always write this equation. K by J is equal to tau by R, which is equal to GT. Instead of, I have to use pi here. I have to use pi here, but I am using theta. But you should understand pi is rate of twist per unit length, which is equal to theta by L for pure torsion. But I am using theta. I have to use, actually I have to use pi only here. I have to use pi here. But since most of the text authors have used theta, I am using theta here. I have also used to theta only. But when we derived it in terms of pi. So don't get confused. It has to be pi only. But instead of pi, I am using theta. That you should understand. Why? Because theta is the total twist. Theta, it is the total twist. If you take the towel at the bed cover, if your friend holds at the left end, and if it is around 10 feet, if your friend is rotating in the at the right end, total twist theta at the right end is maximum. At anywhere along the length from 0 to L, it varies, isn't it? Theta varies. It can be 0 at the end, where is holding, and maximum at the end where you are applying the torque. Okay, this total twist. And also shear stress and shear strain varies linearly depending upon radius. This has to be g theta, which is nothing but pi by L. Okay, based on strength criteria, I also always should take T by tau is equal to J by R. Why? Because strength in the sense This shear strength has to come into picture. Torque is given, shear stress is given, T by tau is equal to G by R. Now T by tau, T is 25 into 10 power 6 by tau is 80, which is equal to J by R is pi d cube by 16. J by Zp, which is equal to J by R, which is equal to pi d power 4 by 32 by d by 2, which is equal to pi d cube by 16. Okay, or 25 into 10 power 6 into 16 by 85, which is equal to d cube. Tell me what is d. Based on, tell me d, rigidity criteria. I can design my shaft. I can find d, l and other things. Design the shaft based on the strength criteria and rigidity criteria. Strength criteria in the sense I'm talking to tau. Rigidity criteria in the sense I'm talking about theta. Which is not pi. What is d?
116 point.
116.75 mm. Now let us see rigidity criteria. T by j, which is equal to tau by r, which is equal to g theta by l. As soon as I say rigidity criteria, we should take these two terms. T by j is equal to g theta by l. T by j, which is equal to g theta by l. This is how we have derived. Okay. Next, I can say uh, t by theta. You can take any t by theta. I'm grouping the terms. That's it. T by theta is equal to gj by l. T is given to be, T is given as 25 into 10 power 6, 25 into 10 power 6 by theta. Theta is 0.0174. Rigidity modulus, you should make a note of this, G, which is equal to 80 into 10 power 3, 80 GPa, 10 power 3 Newton per mm square, 80 into 10 power 3 into J pi d power 4 by 32 into length is 20 times the diameter. Length is 20 times the diameter into 20d. Pi d power 4 by 32 L 20d, or 25 into 10 power 6 by 0.0174 in is equal to 80 into 10 power 3 by into pi d cube by 32 into 20. Tell me what is d? Cross multiply and tell me d.
153.94, sir.
Okay, 154 mm. Which one will be suitable for the shaft? Either this 116 pounds, which one will you choose, 116.75 or 154 mm? Can you give the justification? Which one will choose? Which one will choose? There are two diameters which you got from two criteria. We have to choose the maximum one, because if I take 116.75 mm, then my shaft may not be able to withstand this 1 degree of twist. It will fail. This will not be able to sustain 1 degree of twist. It will fail. If I take 1 degree of, if I take 150 mm or equal to 154 mm, it will sustain both the strength and twist criteria, the rigidity criteria and strength criteria. Therefore, choosing the maximum diameter, that is d is equal to 154 mm, is the suitable diameter and of the shaft. So therefore, the suitable, you should write like this only. Therefore, the suitable diameter of the shaft is 154 mm. That's it. Okay, so any problem if he has given whether hollow shaft or solid shaft, and if he gives, and if he asks you to design, then you should find the diameter based on the strength criteria and rigidity criteria. In strength criteria, P by tau is equal to J by R. Rigidity, this is how we have derived the equation also. If you go back and see, we are related T by tau and J by R. Finally, we have to T by J and G theta by L, and T by J and G theta by L. This is rigidity criteria, and then we have found a diameter. Maximum of the diameter we choose as the diameter of the shaft. Okay. Next problem will go ahead. A hollow circular steel shaft, as soon as you write hollow. A hollow circular steel shaft has to transmit power 60 kilowatt, 60 into 10 power 3 watts at 210 rpm, at 210 rpm, such that the maximum shear stress does not exceed 60 MPa. Tau does not exceed or equal to 60 MPa. If the ratio of internal to external diameter is equal to 3 by 4, di by d naught, di by d naught is equal to 3 by 4, is it 0.75? 3 by 4, which is equal to 0.75. And the value of torsional rigidity, value of rigidity modulus G is equal to 84 GPa. I will write 84 into 10 power 3 Newton per mm square. Find the dimension of the shaft. D naught is equal to how much? dA is equal to how much? Angle of twist, angle of twist in the length of 3 meter. I need to find the dimension of the shaft, and theta I should find in a length of 3 meter. He has not asked us to find the angle of twist based on rigidity criteria. He has asked to find by using this dimension you find the angle of twist within the length of 3 meter. Okay. This is how the problem statement is. First, right? Power P, which is equal to 2 pi nt mean by 60. Power is given as 60 into 10 power 3, which is equal to 2 pi. N is 210 into t by 60. Can you tell me what is t?
60 Newton per meter millimeter square.
60, 2728.37. Are you getting this?
Yes, sir.
27
2728.
0.37 Newton meter. Always we should express this in Newton mm. 2728.37 Newton mm torque. Okay. Next we need to find the dimension based on rigidity criteria or strength criteria. Since we are given shear stress tau, T by J is equal to tau by R, which is equal to G theta by L. Or I can write T by tau, which is equal to J by R, or T, which is equal to 2728 into 10 power 3, 10 power 3, 10 power 3 Newton mm, right? Or 2728.37 into 10 power 3 by tau. Tau is 60, which is equal to hollow shaft pi d naught power 4 minus di power 4 by 32 into this number d naught by 2. I will take in the numerator to the numerator 2 by d naught, or 2728.37 into 10 power 3 by 60, which is equal to pi by 16, pi by 16 d naught power 4 minus di power 4 by 16 d naught, or I can write 2728.37 0.37 into 10 power 3 by 60, which is equal to 5 by 16. Shall I take this as d naught power 4 as common into 1 minus k power 4 by d naught, which is equal to 5 by 16 d naught cube into 1 minus, okay, okay, dA by d naught is given, it is 0.75, 1 minus k power 4. Tell me what is d naught. I thought that, okay, tell me what is d naught. 2728.37 to 10 power 3, 2728.37 into 10 power 3 by 60, which is equal to this d naught will be equal to this 1 minus 0.75 raised to power 4 by 16. This 69.71 mm,
Yes, yes.
69.71 mm. dA by d naught is equal to 0.75. Therefore, dI, which is equal to 52.284 mm. Give me a moment. Okay. Yes. We have find dA and d naught. Then we are asked to find theta. Okay. If theta would have been given, I could have been designed based on the rigidity criteria also. He has asked to find theta by using this expression, or T by J, which is equal to G theta by L. T is how much? 2728.37 into 10 power 3. 2728 2728.37 into 10 power 3, okay, by 5 into d naught power 4 minus, shall I write directly for understanding, also solve two more problems like by di power 4 by 32, which is equal to rigidity modulus is 8 is 84 84 into 10 power 3 into theta by length is, you should always, students make mistakes here, length is 3 meters, it has to be 3000 mm by 3000, or 2728.37 into 10 power 3 into 32 by pi into d naught power 4. D naught power 4 is 69.71 and 52.84. 69.71, 52.28428 is per 4, which is equal to 84 into 10 power 3 by 3000 into theta. Tell me theta, which will be in radians. How much you are getting? Is it 0.0614 radian? 0.0614 radian. Are you getting this answer? Are you getting this answer? 0.0614 radian.
Yes, sir.
Okay, convert it into degrees and tell me. Therefore, theta, which is equal to 0.0614 into 180 by pi, which will be equal to how much? 3.52 degrees. 3.52 degrees. Okay. Next problem, we go ahead. All problems are similar. If I am solving the typical problems, so that you can solve all the problems. The problem statement is like this. A solid circular shaft, has 40 mm diameter. Diameter is equal to 40 mm. When a twisting moment of 1 kilonewton meter is applied, twisting moment is the torque 1 kilonewton meter, which is equal to 10 power 3 newton meter, which is equal to 10 power 6 newton mm, is applied. Determine the shear stress induced at the center. What is the shear stress induced at the center? What would be the shear stress induced at the center? At 10 mm from the center, and outer radius is diameter is 20 mm, outer radius is 20 mm. Also draw the sketch showing the distribution of the shear stress. Also the shear stress distribution of shear stress. Shear stress distribution is linear, 0 at the center and maximum at the outer corner. We know that T by J is equal to tau by R, which is equal to G theta by L. Since T is given, the tau we should find. T is given, tau we should find, or I can write tau is equal to TR by J. Tau naught, which is equal to radius at, let me write, center of the fiber, center of the shaft at R is equal to 0, tau is equal to tau naught which is equal to R is equal to 0 will be equal to 0. At R is equal to 10, tau is equal to tau 10, at tau 10 which is equal to 10 into torque is 10 power 3 by J pi into 40 power 4 by 32 Can tell me tau 10? Are you able to understand this? Same expression writing here, TR by J. T we know 10 power 3 and R we know 10 mm, pi d power 4 by 32 taken to the numerator. What is T10? Tau 10? Is it 39.78 MPa? Tau 20, which is equal to T R20 by J, which is equal to tau 20 is at R is equal to 20, tau is equal to tau 20, which is equal to R20 as radius at 20, which should not write, which is equal to, let me write it as 10 power 3 into 20 by J pi into d power 4 is 40 power 4 into 32. Can tell me tau 20? Hope this is clear. T R by pi d power 4 by 32. Is this clear? Tell me tau 20. How much? Mekala, Raghavendra, Rakesh, Sugan, Sushil, Shruti? 79.579.
Megapascal.
79.62.
Okay, 79.62 MPa. So let us plot how the shear stress distribution looks like. This is a cross section of the shaft. This is the, I'm just drawing on the horizontal line, or you can draw anyhow. It can represent and represent in the vertical fashion only. This is the vertical. Shear stress is maximum at the center. From the at the center it is zero. Tau is equal to zero. Shear stress is maximum at the outermost fiber, which is equal to this is maximum 79.579 tau 20. Anywhere between tau is equal to 10 is nothing but 39.78 at tau radius 10, which is nothing but 39.78. This is tau 10, which is equal to 39.78. This is how the shear stress distribution will be. On this side it is also same, maximum 79.579, like this. Why? Because due to complementary shear stresses, this is how the shear stress distribution will be. Okay, therefore the distribution of shear stress is linear, being maximum at the center, maximum at the outermost fiber, and zero at the center. Okay, this, this is about this topic for the shear stress distribution. We have discussed this. Okay, it is zero at the center and varies linearly. This is how it varies linearly. And anywhere in between, it has a value between 0 and 79.579 MPa in between any point if we take here. Okay, next problem. A solid steel bar of circular cross section has diameter 40 mm. This is solid steel bar, 40 mm is the diameter. Length 1.3 meter. Length 1.3 meter, which is equal to 1300 mm. And shear modulus of elasticity or rigidity modulus, which is equal to 80 GPa, which is equal to 80 into 10 power 3 Newton per mm square. The bar is subject to torques T acting at the ends. Okay. Now the first statement. If the torques have the magnitude 340 Newton meter, what is the maximum shear stress in the bar? What is the angle of twist between the ends? If the torque is equal to 340 Newton meter or 340 into 10 power 3 Newton mm, okay, what is the maximum shear stress? Tau max is equal to how much? Okay, and angle of twist. In the previous problem, another 10 minutes remaining. If it's not possible, try to complete in the next class. In the previous problem, this diameter was not given, whereas tau max and theta were given. We used to calculate d from this data. In this problem, diameter is given. I need to calculate tau max and theta. This is first part. Next, if the allowable shear stress is 42 MPa and angle of twist is 2.5 MPa, what is the permissible torque? If the allowable shear stress tau max, which is equal to 42 Newton per mm square, and angle of twist theta, which is equal to 2.5 degree, What is the maximum permissible torque? What is the torque? A torque max equal to how much by using the same DL and G. Okay, this is the given problem. First, but as usual, when the problem is given, go ahead and write this equation. T by J is equal to tau by R is equal to G theta by. Half of the problem will be split up. T by J is equal to tau by R is equal to G theta by L. What we need to find? We need to find the shear stress and the angle of stress. Shear stress in the sense, we'll take the first part. T by J is equal to tau by R. T by J is equal to tau by R, or T into R by J is equal to tau, or tau is equal to T as given as 340 into 10 power 3, 340 into 10 power 3, R in the sense radius, which is equal to 20, 20, let me write, PR by pi d power 4 by 32, which is equal to, which is equal to TR by pi d cube into 32. Okay. Next, generally we express R as d by 2, but I have written that since I know R. Okay, pi TR by pi d cube R, that 340 into 10 power 3 into 20 by J pi into pi d power 4, d power 4 in the sense 40 power 4 into 32. Tell me my tau, what is the value of tau? Is it 27.05 Newton per mm square? Are you getting this? Are you getting this?
Yes, sir.
Okay. Next, he has asked us to find my angle of twist. He has asked us to find angle of twist. For that, I will use this 2. T by J is equal to G theta by L, or TL by TL by Gj is equal to theta, theta which is equal to T, which is equal to 340 into 10 power 3, length is given as 1300 mm into 1300 by G, G is 80 GPa, 80 into 10 power 3 into pi into d power 4 by 32. Okay, tell me what is theta. 340 into 10 power 3 into 1300 into 32 by 80 into 10 power 3 into pi into 40 power 4. How much is it? 0. 0.0. Yes, 0.0. Yes,
21.
219.
2198 radians. Tell me in degrees. 0.02198 into 180 by pi, which will be equal to how much? It is 1.259 degrees. This is first part. Next, part A is over. The second question, he has asked, given tau max and theta, given tau max and theta, calculate torque maximum. What should be torque maximum? Now, by using this dimension, by using this tau max and theta, we should find what is the maximum torque and given this dimension. Okay, that can be done by two ways. First, based on strength criteria, T by J, which is equal to tau by R, which is equal to G theta by L, or T by tau is equal to J by R. I am taking the first part. T we know, T we have to calculate. What is the maximum torque is it constant, or T is equal to tau is given as 42 MPa, 42 into J, pi into diameter, what is 40 for 4 by 32 into 20. Tell me T, or I can also do it by based on based on rigidity criteria. Rigidity criteria. Torque can be found out based on strength criteria and rigidity criteria. Also, design can be done by rigidity criteria and strength criteria. There is rigidity criteria and torsional strength. That is T by tau. That is strength criteria. T by J, which is equal to G theta by L. T is equal to Gj into theta by L. T is equal to G is how much? ATGPA, no? ATGPA, AT into pi into T power 4, 40 power 4, 40 power 4 by 32 into length. It's 1300 mm, 1300 mm into theta. What in the angle of twist of 2.5 degree. Theta is given as 2.5 degree, equal to theta, which is equal to 2.5 degree, or theta is equal to 2.5 into pi by 180. Tell me, substitute and tell me this. What is T from this? What is T from this? T from strength criteria, it's 527.78 into 10 power 3 Newton mm. T from rigidity criteria is 674.79 into 10 power 3 Newton mm. Which did you got the same answer? Did you got the same answer? Nikala, Raghavendra, Rakesh, Sugun, Sushil, Dutti, did you got the same answer? Theta is equal to 2.5 into pi by 180. It should be in radians. 40 for 4 by 32 into 1300. How much you got T based on strength criteria? How much, Raghavendra? Hello?